These are your 1-4 notes on the distributive property. So we are going to use the distributive property to evaluate, where we'll actually get a number answer, and then we're also going to use it to simplify, where we'll have variables left in the answer. You can't do anything about that, but you can make the answer simpler looking. So like terms in an expression are terms in the equation or expression that share either, well, they share the same variable raised to the same degree. So you have to have both parts in order to be like terms. So same variables, an x with an x, a y with a y, an ab with another ab, but they also have to be raised to the same degree. I like to say birds of a feather flock together. So if you have a like term, you can have a 2x and a 3x are like terms. They're both x to the first degree. Who cares about the 2 and the 3 out front? If I have an x squared y cubed, I have to have another x squared y cubed in order to be like terms. So you can have more than one variable, but they have to be raised to the same exact power, each of them. The numbers out in front don't matter. So even though there's no number there, we could put a 1 in front of there as well. So it's sometimes helpful to look at what is not a like term. So if I have an x and a y, not like terms, obviously, because they're not the same variable. If I have an x squared with an x, still not like terms because they're both x's, but one's raised to the second power and one's raised to the first power, so not alike. I can have an x squared y, but it's not the same as xy squared. Even though they both have squared, you got to look carefully at the term that's squared. Something else I like to show in the likes that I forgot about and I just remembered, xy and yx are like terms. They are the same variables raised to the same degree. They're just in a different order. So that's the lesson on like terms. So in this particular case, the coefficient is the numerical factor of a term. And actually, I see a mistake on my notes. If you would make that an exponent. I don't know why that didn't go up as an exponent. So in 2x cubed, the coefficient is 2. It's the numerical factor. In negative 4y, the coefficient is negative 4. In negative m, the coefficient is actually the number in front of that negative, which is negative 1. And when you have n divided by 3, if you remember from a couple lessons ago, that's really 1/3 times n. So the coefficient would be 1/3. So I had to explain what a coefficient was before we could talk about combining like terms, because when you combine like terms, you need to add the coefficients of the like terms. So it is just that. We combine like terms. We're going to put them all together. If I see x's in the front of the equation and x's way in the back of the equation, I'd like to condense them and make just one section of x's. So it simplifies the equation and expression. So we're going to talk about simplest form as you go on through your math levels. But right now, in simplest terms, you're going to eliminate grouping symbols. So if you see parentheses or brackets, you want to get rid of them by multiplying, adding, squaring, whatever you have to do. And then you're going to put the like terms together if you can. So let's just go through a couple of examples of that. So it says simplify the following expressions. If not possible, write simplify. Just say, hey, I can't do anything to this. So I have 3 x's here and I have 4 x's here. There's a better way to say that. I'd rather just add the coefficients and say that there are 7 x's. So I think of like sweeping them into a pile, putting all your x's into an x pile. Okay, notice the x didn't change. I still have 7 x's. There were 3 in the front, 4 in the back. Now I put them together. I have 7 total x's. I have 15m out in front. I have 1m in the back here. So I have a total of 16m's. You're just telling me how many of that variable you have. In number 3, I don't have like terms. This is x cubed. This is y cubed. You can't put them together in the same pile. You can't say I have 7 of something because you don't. You have 3 of one thing and 4 of another. So you just write simplified. Understanding that is just as important as doing this simplification. Now, number 4, I really threw out all the stops. So sometimes it's helpful to color coordinate if you have highlighters, underline, circle, maybe put a box around things. So I have a 2a squared here. I'm going to search all the way down the line. I see another 1a squared here. I'm going to put a 1 there so I know. So I have a 2a squared and a positive 1a squared. That's a total of 3a squareds. Then I keep looking, and I have a negative 5a here. I just circled it just to kind of give a different reference. I'm going to look for all the different a to the first along the line. I circled the positive 3a. Notice I keep the sign with it. I have negative 5 out in front. I have positive 3 in the back. That means I have a negative 2a left over when you add those together, a negative 5 plus 3. And then I have a positive 3 here, which is just the coefficient, just as important as the variables. And then I have a negative 7 here. So the numbers that don't have variables can also be combined. So positive 3 and negative 7 make negative 4. So that is your simplified statement. I can't get a number. I can't evaluate it because I don't know what a is equal to, but I can condense it. I can make it simpler looking. That's the whole idea of simplify. So the distributive property, I think you guys are all familiar with, uses 3 terms or more. And so in this definition, if you have a number on the outside of parentheses, outside of a sum or outside of a difference, it doesn't matter where the actual parentheses are in the number that you're multiplying by. So the number you're multiplying by can be in the front or the back. But in the end, it is equal to, you can distribute. So instead of adding the b plus c together first, you can simply do the multiplication first, and you multiply everybody inside. So a times b plus a times c. And the subtraction, same thing. You just distribute, just like I pass out papers to everybody in class, you distribute the a multiplication to every number inside the parentheses. And so that would just take the sign of the negative there. So we use the distributive property as another method to evaluate expressions and also as a method to simplify an expression. So if you look, it's actually a nice way to do math that isn't so kind. So if you look at using it to evaluate, I have a table here of showing you how to use the evaluate using the order of operations, but then also using it, same problem, just slightly different. So if I look at the first one here, order of operations would tell me that I have to add the 7 and 2 first. That makes 9. And then 5 times 9 is 45. Using the distributive property, I could do the same thing, but not add 7 plus 2, but simply distribute the 5 through. So 5 times 7 first, plus 5 times 2, which gives me 35 plus 10. In the end, we get the same answer. So I made it an extra step there. I probably wouldn't have to make it that extra step. I could have taken out this and just did that step in my head. So it's not any more work, it's just different work. Now, I would probably stick with the order of operations method here. But in the example below, it may be to your advantage to use the distributed property rather than trying to evaluate 4 times 498. So using the order of operations, I would actually have to 4 times 498, without a calculator, do the actual math longhand. But if I use the distributive property, I know 498, I can rewrite that. It's really close to 500. In fact, it's 2 less than 500. So if I replace 498 with a quantity, 500 is really easy to multiply with, and 2 is really easy to multiply with. And so this is just another representation of 498. When I use the distributive property, 4 times 500 is 2,000, and 4 times 2 is 8, and 2,000 take away 8 is that 1992 again. So I know you guys all have calculators, so it's hard to understand that. But that process is really nice when you don't have a calculator handy. Then we can actually go ahead and go through each of these different examples to either simplify or evaluate. So again, for this first one, I want you to use a distributive property. I don't want you to use order of operations. 3 times 5 is 15. 8 times 3 is 24. So 15 plus 24 is 39. For number 2, if I have a negative, I just distribute the negative as well. Negative 2 times 4 is negative 8. Negative 2 times a positive 7 is negative 14. Negative 8 and negative 14 make a negative 22. And then this 108, I'm actually going to make that 2 times. It's just 2 less. Actually, I can do 8 more than 100. I could have done 2 less than 110, but I might as well just use 100. So 2 times 100 is 200. And 2 times 8 is 16. So I end up with 216. And you could check your answers with the calculator. To simplify, I can't get an answer for this because I don't know what any of these y's and x values are. So all I can do is make it simpler, make it look better. And so one of the first tools we use is to get rid of the parentheses, and to do that we would distribute. So 12 times 1y is 12y, and 12 times a positive 3 is a positive 36. I would look to see if there's anything else that can be combined. There isn't. So this is the simplified form of that expression. I got rid of the parentheses. Same thing for 5. I'm going to take this 4 through. Sometimes it's helpful to draw arrows showing you that you're multiplying every single term inside there by 4. 4 times y squared is 4y squared. 4 times 8y is a positive 32y. And 4 times negative 2 is negative 8. Don't forget those signs. I look to see if there's anything that can be combined, but I can't. One's a y squared, one's a y, and one doesn't have a y at all. Down below, I'm going to distribute twice. So I'm going to distribute the 6 through the first set. That gives me 6 times x plus 6 times y. And then I'm going to distribute this positive 4 through the second set. Positive 4 times 5 is a positive 20x. Positive 4 times negative y is negative 4y. When I look back through the problem, I notice that there's 6x out in front and a 20x here in the middle. So that could be rewritten better as 26x. A positive 6y and a negative 4y tells me I have positive 2 y's left over. You can't put the x's and y's together, so that is the simplest way we can represent that problem. So your lesson summary is to identify the coefficient of that particular term, and your practice problem is to use that distributive property and the simplification rules to simplify that. So I'm assuming you're going to have to distribute and then look for like terms to combine. Good luck.